Hello, let me go over the solution for ANOVA homework. Um, this homework, you had several problems and you were trying to look at the calculation, the output I provided you to answer the question. Let's go over the first question. Uh, uh, Question one, we have a researcher wanted to examine the physical activity of nursing a student based on their year in a school, which we define it as four level, freshman, sophomore, junior, and senior, and how he can use to test if their physical activity is different for those years. So the first question is what type of a statistical you use is analysis of variance or ANOVA because you have more than two level. If it was two level, you would use t-test. So the A part correct answer is ANOVA. Then basically writing the hypothesis, you have four level. So your null is mu1 equal mu2 equal mu3 equal mu4, and alternative is at least one mean is different, is not equal. One of the comparison, remember you have four level, you can have several of comparison, pair comparison. What alternative says is at least one of those comparison could be different. So that's question one. Question two, we have three methods to reduce the stress, the method 1, 2, 3, and we have 5 subjects for each method. We wanted to know, I asked you to calculate either using the table I provide you or by hand, you could calculate sum square between and within total and your F value. So basically, looking the output, you can easily find those from the table. This is your ANOVA table. Sum square of model or between is the A part is 368.5 within 244.40 for a B part, and the total 612.9, and your F value is 9.05. And this is your P value 0.004. If you testing if we at alpha 0.05, since the p-value 0.004 is less than 0.05, we said we're going to reject the null and conclude there is at least one means are different. Now, if you calculate by hand, you can do that by hand based on the information I give you. Basically, sum squared between is you have your means for each group minus the grand mean squared times the n. You add up, you get the same response. For sum squared within your n minus 1, you have here the variance for each group. Basically, you multiply by that and you get that the total would basically adding up. Then you can create the same ANOVA table as I provided as your table. Basically, you have three groups. Your 3 minus 1 would be 2. 15 minus 3 is your n minus k, which is your number of level, 12. And basically, you get your mean square dividing 368.5 by 2, 244.4 by 12, you get this. And dividing 184.25 divided by 20.37, you get 9.05. So if you use by hand, you should get the same result as provided here in the table. So that's question 2. Now question 3, you have this output, Bonferroni method and Tukey method. I ask you to see which statement is correct. Remember, when you have three groups here, basically group 3 versus group 2, group 3 versus group 1, group 2 versus group 3, these are three comparison. So 1 versus 3 is the same as 3 versus 1, so you count it as 1. So here when you have asterisk, 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 that means it's significant. Or what you can look at it, if 0 is not in your confidence. See here, negative goes to positive, 0 is in confidence. That means it's not significant. But if 0 is not in the confidence, like here, if you have two negative value or two positive value, the 0 is not confidence, that means it's significant. So here, based on the two key method, the only group 3 and group 1 is significant. And based on the bond-Froning method, you remember you're going to look at the connection letter. So group 3 and 2 connected with letter A, that means they're not significant. Also group 2 and 1 is connected with each other, that means it's not significant. The only comparison left is group 3 versus group 1, which there is no common letter connected to that group, that means it's significant. So basically both methods show group 3 is only different from group 1. That was the correct answer. Now question 4, we have two variables here, working status if they work no and yes, and type of physical activity if they did none, light, and moderate. So you have 3 level by 2 level. So this design called 3 by 2. And so these are the individual responded to that. So I ask you using the output, so you find the information, and so what is the F value? Basically, your F value here is from ANOVA table is 25.38. That's the correct answer. Now, here the B part, I ask you to examine the main and interaction effect. Remember, there are two types, type 1, type 3. You're going to use type 3 because type 3, each effect is controlling for the other effect. Like here, A is factor A, which is our physical activity, after controlling for working status and interaction effect. Factor B, which is our working status, is testing after control physical activity and interaction. So here, if you look at this last column is your p-value. If the p-value is less than 0.05, is significant. So both physical activity and working status, the p-value is 0.0001, less than 0.05. That means they are significant. If you look at the interaction, 0.54 is not, it's greater than 0.05, therefore is not significant. So in the B part, what correct answer is just both factor A and B, which is your physical activity and working status, correct answer. Now, what is the result of adjusted Tukey for factor A? So you're looking at Tukey factor A, which is your physical activity. You have 3 groups. The means for light is 18, and moderate to light is 13.35, and 9, 21.67. Remember that those are the means for your outcome, which is here is anxiety. So the higher score means you have more anxious. So basically here, group 1 is labeling for you 1, 2, 3 as light, moderate to high, and none. 1 versus 2 is significant. 1 versus 3 is significant. 2 versus 3 is significant. If you look at all the p-value here, all is these 3 p-value. You have 3 comparisons, then you have 3 p-value. All of them is less than 0.05. Therefore, you would say group light is different from moderate and none. Also, group moderate is different from none. All those 3 comparison is significant. That's the correct answer. So that's question 4. The question 5, we have depression. We were measuring our outcome is depression. We have 3 treatment and gender. So again, the design is the same as the previous example, 3 by 2. I ask you to find the same for using our output finding the same answer the question. What is the F value? 64.7 for A part. And examining against the effect, you're looking at type 3. If you look at all of these p-value is less than 0.05, so therefore you say factor AB and interaction is significant. Now, question C, I ask you how many significant difference you see in adjusted 2 key. If you look at the 2 key, remember you have here basically 6 group, which is treatment 1 female, treatment 1 male, treatment 2 female, treatment 2 male, treatment 3 female, treatment 3 male. And remember, you need to look at the when you're looking at the metrics, if they're above diagonal, the empty diagonal, or below. So these are the significant one. You have 1 versus 2, 1 versus 3. I highlight all those significant. 1 versus 6, 2 versus 4, 2 versus 5, 3 versus 4 and 5, 4 versus 5, 6, and 5 and 6, 4 versus 5 and 6, and 5 versus 6. So if you count the number of significant 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 of those comparison is significant, which is the correct answer. Question 6, I was asking you looking at the table 1 and see what kind of test was done. Remember here you have more than 2 levels, so the correct answer is analysis of variance. How many groups were examined here? There are 4 groups. If you look at no disorder, axis I order, no comorbidity, and axis I comorbid. So there you have 4 groups that you see the means and standard deviation be reported. And the last question I asked, which variable were significant? The variable in table were noted by the p-value with a star and double star. These 2 p-value, education and income, were less than 0.05. So those were both education and income were significant. I hope this helped you to understand better the content of analysis of variance and ANOVA.